Let's begin this chapter by saying chemistry is definitely not a spectator sport. I know that's a couch potato eating some chips, but if you haven't plugged in yet in chapters 1 and 2, please start to do so now. Um, I, I just have to say these things because it sets the tone for the course. You are going to have to apply things in this course. And you may not really understand it. We'll have discussions with students. They'll say, I didn't understand this, therefore I couldn't do it. You have to be able to apply it within the context of our course. And the number one thing we do in this class is facts, which you have to remember. Once you start to remember the facts, then you start to get to Bloom's taxonomy where you start to understand things. This takes time. It may not take place before midterm 1, it may not take place before the end of the term, but we've written the exam such that you can apply, that's number 3, what we've covered in this class within the context of this course. You just have to trust me at this point. Okay, so you're going to need to solve problems. Some of them will be word problems, some of them will involve calculations in order to master chemistry. And I put a little thing here. I said, use your time wisely. Don't spin your wheels. Have you checked the time management function of ALEKS? That can help you plan the time you need to learn Gen Chem. I was pretty amazed to see that you could actually predict how much time a student would need to master certain topics. So what am I going to stress? Well, I'm going to stress that when you're doing a problem, you should write things down. It should not be done in your head. It should be done neatly because that will most likely lead you to the conclusion. Once you write down your data, what plan are you going to use? I mean, people say, oh, chemistry is just memorization. But it's not memorization. It really is thinking. And so you've got to get a plan. Are you going to do it in one step or later on in this, before the next midterm? It's going to be a multi-step problem. Then what you need to do is solve that problem. I love math. So to me, I love a math problem with equations. But the people who write your exams, they enjoy conceptual problems, and they're going to put in more relationships. So we really want to practice enough so when we sit down to take these exams, we really feel confident in approaching them. And finally, once you get an answer, I, again, am a math person. I worked in industry. Significant figures, units. I mean, that's what you need if you're going to give a product to a customer. Sometimes you never understand how something works, but you definitely can deliver, okay? Off the soapbox. Now, we once again have the same format where every section of the chapter has some assigned end of chapter problems. I am hoping the ones in bold are covered by your TAs in recitation. I will encourage them to do it. I will drop into your Zooms and see how things are going. So here's section 3.1, chemical equations. What's going to happen is the letters that we have in an alphabet, they're going to be the elements now. Maybe you figured that one out. The words that we use in a sentence, they're going to be the compounds that we are going to use to write in our chemical equations. And I have here, chemical equations are stories, and they have phases. So think of the phases as punctuations, commas, periods, exclamation points. So let's do an example. You see my bad joke in the corner. It said, I told a chemistry joke and there was no reaction. Isn't that really bad? And sadly, I can't see all your faces to see how you're rolling your eyes. In chapter 2, you learned how to write all of these chemical equations. And that's what we want to do right now. We want to say, I know what nitric acid is. It is HNO3. And it tends to be an aqueous solution. I am going to react that plus copper. Copper is a solid. It is a transition metal. I'm going to do it in the presence of oxygen. And I'm going to make a red-brown gas that is labeled nitrogen dioxide, NO2 gas. And I will also make some copper nitrate. Now again, at this point, you don't know phases, you really can't balance. I'm kind of stringing you along. But notice, nitric acid, HNO3, copper is the copper solid, NO2 is the red-brown gas, and copper 2 nitrate, you know how to make that formula. So we have elements, we have compounds, and we have a chemical equation with punctuation, which are the phases. Now, this concept, I don't have many slides here because if you can grasp it here, you're golden for the rest of the course. Stoichiometry, that is a relationship, and it is a quantitative relationship between chemical formulas of substances and equations. I tried to use some color. Notice in the equation there's an H with a blue 2, an O with a blue 2, and an H2O with a blue 2. Those subscripts, they are for the substance. You cannot change them, okay? If you're given a chemical equation, they have to be set no matter what. What you will be changing are the stoichiometric coefficients. That is for the equation, and what you're going to teach yourself to do is you're going to learn to balance an equation. We only give you certain ones that we know you can handle now. We're not going to give you really hard ones. But if I look at my very simple example of water, the red are the stoichiometric coefficients. Notice I had to put a 2 in front of the hydrogen. I had to put a 2 in front of the water. Why did I do that? Well, let's look at the hydrogen and let's look at the oxygen. Let's look at the number of reactants and let's look at the number of products. For my hydrogen, I have 2 times 2, the blue times the red equals 4. For my products, I have 2 times 2 equals 4. I have mass balance. For my oxygen, I have the diatomic oxygen, and 2 times 1 equals 2. I have mass balance because I put the right stoichiometric coefficients. Without those letters 2, things would not have worked. I would have had just 2 hydrogens on the left, 2 hydrogens on the right, 2 oxygens on the left, only 1 oxygen on the right. So again, I did it for the balanced equation, and you'll have plenty to practice on where things will not be balanced. So is this really hard? Not at all. If you can't follow what I did on the last slide, please step back. But what I did here is I did the combustion of methane. CH4 plus oxygen makes CO2 plus water. What I did here is I counted how many of each element I had. Notice I have 4 hydrogens and 2 hydrogens, 2 oxygens and 3 oxygens. This is not a balanced equation. So what you have to do is adjust the stoichiometric coefficients. There is no memorization. There is no magic. What it is you just trial and error. What can you do in order to make this balance? So when I put a 2 in front of the oxygen and I put a 2 in front of the water, what I then came up with are a balanced chemical equation. So again, I shouldn't have a 4 here. I shouldn't have a 2 here. This should become a 4. I should not have a 3 here. This should actually be a, let's just fix it here. This should really be a 2 plus 2, meaning a 4. Here we have a 2 times 2, and essentially that should also be a 4. Is this a mistake on this slide? No, actually not. I did it on purpose because I wanted you to focus and to see what's really going on. So nothing happened with the carbons. Hydrogens had to be balanced by putting a 2 in front of the water, and oxygens had to be balanced because there were 4 on the product side and only 2 on the reactant side. So again, it's going to take some thought, and we're only at the beginning of chapter 3. Please, please ask questions. Zoom us. I'd say that's the best way. If you're going to send an email, be very, very specific. The other thing I need to mention is you have to include the states: gases, liquids, and solids. Sometimes because we're online, I don't have my giant blackboard in McPherson 1000. I have to take some shortcuts. But when you're balancing an equation, you do need to put in one of the 3 phases of matter: gas, liquid, or solid. And aqueous stands for something in water. Last slide, okay? This chapter, it's going to set the stage for the rest of the course. please don't use answer keys as a crutch. I know you can, well, let's just say you can use any device when you're taking an exam. You're not supposed to. But really, if you learn this starting in these early chapters, you will have success in this course. And I know it's a pain in the neck. If you're trying to solve problems, it's like trying to play a musical instrument. My son played the trumpet. It was awful. When he was in 6th grade, it sounded like a squeaky door. It was awful. But he did play Carnegie Hall as a college student, and, he did get better over time. In terms of a sport, my favorite is running. I am a runner. And you don't run real fast. You don't run a marathon unless you change. So that's where the couch potato comes in. You can't get better just by watching someone solve a problem. Pick up your own pencil or your Apple Pencil and start practicing. So I don't know if you've ever read the Malcolm Gladwell book where he said you need 10,000 hours to be an expert. I don't know if I buy into that, but a lot of practice can help you be very, very successful. Now, I want to say, if you're not doing as well as you like, please take a look at those ALEKS problems. That is why I chose it. People gamed mastering. People said it was busy work. I honestly could not stand putting up with that anymore. ALEKS is something that takes you where you are and it lets you build and grow. So give me some feedback. I've never used it, but I am sold on the concept. And artificial intelligence is a way of life. Big data is now a way of life. So as you learn this in chemistry, I am hoping you can apply it in your real life profession.